Okay, hi guys, sorry I can't be there today, but we're going to do ionic compound notes, so you probably want a piece of paper to write it down. You also want this sheet, the polyatomic ion sheet you got when you walked in, and it has all the polyatomic ions, and you will have it on all tests and quizzes, so this is one you want to keep with you. And you probably want to have out your periodic table as well. Okay, so ionic compounds. First thing is that they are formed by ionic bonds. Imagine that. Okay, and they are always going to be between a metal and a nonmetal. And that makes sense to us, right? Because if we look at our periodic table, well, we'll get there in a minute. Okay, and for metals, when they form ions, they form cations, right? Because they want to give up electrons, want to give them away, and our nonmetals form anions. So we can say ionic compounds form between a metal and a nonmetal when they become cations and anions. And we've talked a lot about Lewis dot diagrams and molecular compounds and sharing of electrons with covalent bonds, but ionic compounds are the other type of bonds. And remember, our octet rule says that atoms can gain, lose, or share. And so ionic compounds form by giving and taking of electrons. Okay? So let's look at how this happens. Let's start with our first very well-known ionic compound, sodium and chlorine. Let's think about the Lewis dots of sodium. If we look on our periodic table, sodium's on the first column, so sodium has one dot, right? One dot, one electron, okay? And chlorine, right, group 7, has 7 electrons around it. Now, what does sodium want to do? Sodium wants to give its electron to chlorine, right? And chlorine wants to take its electron. As soon as it gives away its electron, what charge does it become? 1 plus, right? Because it gave away a negative charge. Chlorine becomes 1 minus because it took that electron. It became 1 minus. And together, they form the compound NaCl. That's table salt. That's the stuff you put on your french fries. Okay? Now, let's look at another one. Let's look at Ca and Cl. So if we look at Ca, Ca is group 2. So it has how many electrons? 2, we'll think of it. And then we already know chlorine has 7. So calcium, Ca, wants to give away electron to chlorine. But that's not all it wants to do, right? So what can happen here? Because calcium doesn't want to give up just 1, it wants to give up 2. So what does it need to have? It needs to have a second chlorine. When it has this second chlorine, what does calcium do? It gives that second electron to calcium. So if we look at this, when calcium gives away its 2 electrons, it becomes what? Ca, 2 plus, and we have how many Cl1 minuses? We have 2 of them. So we say this forms Ca, Cl2. Now, when we look at this, what are we actually doing here? We're actually just balancing the charges. It gets kind of ridiculous to be drawing arrows to the Lewis dot diagrams, but what we can do is we can look at the charges. So what the idea is that you want those charges to balance out, right? And then that tells you that they have gained and lost that same number of electrons. So if we have calcium with a 2 plus charge and chlorine with a 1 minus charge, we want to make them both equal to 2, which makes we need 1 calcium because it's already 2 plus. Chlorine is 1 minus, so how many do we need? We need 2 of them. We get the formula CaCl2. Okay, let's look at another one. Let's look at, I'm going to write it closer, make sure you can see it, Ca and P, phosphorus. Now if we look at Ca, we're not going to look at its electrons this time. We're just going to look at its charge. Its charge is 2 plus, right? It's in our 2 plus column. Wants to give away 2 electrons, right? We just looked at that here. Now if we look at phosphorus, phosphorus wants to give up 3 electrons. So what's our common numerator? What can we make them both equal to? 2 times something doesn't give you 3, not a whole number at least, and 3 times something doesn't give you 2. But we can make them both, we can multiply them both by something to get 6, right? So if we have Ca, we end up with Ca, how many times? We'd need 3 of them, right? And then phosphorus, we need how many of them? 2. So we would have Ca3P2. So let's make sure we understand how ionic bonds form. Okay, so let's come back here to Na and Cl. What actually happens is the metal, sodium, gives up its electron, right, to the nonmetal, which in this case is chlorine. When it does this, it becomes a cation. When chlorine accepts the electron, it becomes an anion. Now, the reason they actually bond together is because of these opposite charges. They bond together. You might want to put that in quotation marks because it's not a bond because they're sharing. It's a bond because, right, of the opposite charges attracting one another. So that's how that works. Now, what I'd like you to do is get out your chart in the packet. It's the first page of your packet, okay? And you'll see on it, right, you have your chart here, and you have your Na, right, and you have your Cl. What I want you to do is look up the charge, 1 plus, 1 minus, and you're going to fill it in. Oh, but I have to do one more thing. I want to look at one more example before I do that. I want to look at ionic compounds with polyatomic ions. Remember, polyatomic ions, we've bonded together before, right? So we can also bond these ionically. So if we look at them, we've drawn Lewis dot diagrams for polyatomic ions, right? So let's look at this. Let's say Ca, calcium, 2 plus. Then let's look at NO3, 1 minus. Now, if you look at your periodic table, or if you look, so where do I get NO3, 1 minus? That's when you're going to pull out your polyatomic ion sheet. You're going to look for NO3. You're going to see it right here. You're going to see that it has what charge? A 1 minus charge. Okay, and it always takes that 1 minus charge. So that's what you would write in for NO3. So what am I going to do here? I'm going to take Ca. What do I want them both to equal? What's my common numerator here? 2, right? I need 1 Ca. How many NO3s do I need? I need 2 of them. So what I do to show that I need 2 of them is I write NO3 in parentheses, and I need 2. Okay? So you will find some of these on your chart, and so you will look on your orange sheet, you will find their charge, and you will write that. You do not need parentheses if you only need 1 of your polyatomic ion. You only need the parentheses when you need 2. Okay, so I'd like you to go ahead and fill out your chart. Then go ahead and get on Google Classroom. You'll see that it's keyed on there. So once you fill it out, you can check and make sure you are doing all of these correctly. Okay, when you finish that, come on back and check the next Google clip where we're going to learn to name these ions.